Hey everyone, so welcome to week 9 of distance learning. It is our second to last week to go of lessons of new content, and then we'll call it a year and hopefully end on a good note. We have a couple of surprises in store that the math department have been cooking up for that final like last half a week. I think technically our last day is June 9th, I believe. So, which is a Tuesday. So, I'm gonna try to get something out to you guys soon about that. But in the meantime, we're gonna be talking about exponent properties for the second week this time too. Last week, oh, by the way, I hope that by the time you watch this, you will have had a good long weekend, Memorial Day weekend. Um, and it's pretty rainy right now. It's Saturday when I'm recording this. But hopefully, I think tomorrow's supposed to be nice weather, and the day after that too. So hopefully, you guys go out, or by the time you've seen this, have went out and enjoyed it. So this week we're going to talk about exponent properties. We're gonna mention two more properties that come out of kind of just working with exponents and like the definition of what an exponent means. Um, so let's just get started here. So let me see. Drawing. Let's see. What colors am I going to use today? I think I'll use green and purple. That sounds good. So let me start off here. By the way, I'm using this Cami app, which I know some people had some trouble with last week that tried it. You don't have to go through this. Some people asked, do I have to follow along with the notes? Do I have to do this? No, you don't. I'm just using it to provide you with examples as I go through so that hopefully you learn what these two properties are about. I can speak today. Yeah. Okay, so last week we talked about the properties of, maybe I should start, let me start off by like a small review here. Yeah, let's add a blank page. That sounds good. Okay, so last time we talked about two properties. One I just called the multiplication property. Whoa, something's... Okay, hopefully I'll fix this. I think my cursor is a little bit off, which is gonna throw me off a little bit. But we talked about the... Okay, so I don't know why this other page wasn't working, but let me go back and review the two properties that we did last week. We talked about what I call just the multiplication property. And what does that mean? There's a longer name for it. I'm just calling it the multiplication property. And what does that mean? What is that? That is when we have an exponent, say for example, 3 to the 5th power, multiplied by another exponent with the same base, right? Same base, both base of 3. Let's say times 3 to the, I don't know, 2nd power. What does this say? Well, the multiplication property says this is the same thing as 3 to the 5 plus 2 power. Or in other words, 3 to the 7th power. Why is that the case? Well, because remember the definition of an exponent, if we expanded this out, this is the same thing as 3 times 3 times 3 times 3 times 3. So there's 5 of them times, that's this times, and then there's 2 more. So if you expand both of them out and then recombine them into one exponent, we get 3 to the 7th. So that was last week that we this multiplication property. We just said you can just, in other words, you can just add the exponents, or add the powers, sorry. Add the powers. What was the other property that we talked about last week? It was called the power property. Power of a power, or the power rule. And what did that say? That said that when we've got an exponent, say like 3 to the let's do 5 again, and we raise it to another power, say to the 2, what do we do with the powers now? Well, this rule says that we multiply the powers. So this would be 3 to the 5 times 2. We multiply these two, or you can think of it as distributing that power almost, which is 3 to the 10th. And you could get to that the same way that if you expanded this out, this whole expression, and then recombined it, you would get this. So this was the power rule. When you've got a power to raise to another power, we multiply the powers. And you guys had practice on that. By the way, thank you for doing it for those of you who went out to IXL. I saw great engagement this week, which was fantastic. I don't know if that was partly because I assigned IXL, which you're more familiar with. I've been using a couple different tools now. Maybe I should have just stuck with IXL from the beginning. In the hindsight's always 2020, right? This is all kind of experimentation, really, for next year, when I think we're going to have some more distance learning, but hopefully synchronously, hopefully at the same time, just virtually. Anyway, so these were the two rules that we talked about last time, the two properties. What are we going to talk about this time? This time, we're going to talk about we're going to do the property of division. We're going to talk about negative exponents and using the power rule again. So let's start off here. Let me switch back to purple. I like purple. It's a regal color. Huh? Okay, so first thing here, expand the following expressions. Right, so we're just talking about using the definition of an exponent. Let's expand these. What is 2 divided by y raised to the power of 5? Well, remember, the power of 5 means we're just multiplying whatever's inside these parentheses by itself that many times. So if we were going to expand this out, it would be 2 divided by y, right? I'll leave it in parentheses for now, times 2 divided by y. Oh boy, why did I choose 5? Times 2 divided by y times 2 divided by y. And there should be a fifth one, 2 divided by y. I have to group these a little bit tighter next time, right? That's just expanding it out. And it just says expand, so that's all I'm saying here. How about this? How could we expand this out? I'm not saying simplify, I'm just saying expand. So it's x to the power of 2, right? That's x times x on top of this fraction. You'll see all of these examples we're going to do today involve division, which basically just means fractions. Something divided by something else. X times x on top. What's on the bottom? We've got x to the power of 5. That means there's 5 x's. 1, 2, 3, 4, 5, all being multiplied. And y to the third means there's also 3 y's on the bottom. Okay? Again, we're just expanding this out. All right, last but not least, let's expand this out. X to the power of 2 divided by y, all to the power of 3. That means we're going to have this inside parentheses again 3 times, right? So let me just start it over here. We'll have x to the power of 2 divided by y, in parentheses, times x to the power of 2 divided by y, times x to the power of 2 divided by y. Simple. I wrote it 3 times, and there's implied multiplication between these. Okay, what else do we have? Now let's talk about simplifying expressions. So we've got these expanded expressions. Let's talk about simplifying those, rewriting them back as an exponent. All right, so, what exponents do we have here? We've got a bunch of 4s on top, right? So we've got to think, let's see, how many 4s are being multiplied? 1, 2, 3, 4, 5, 6. So that would be 4 to the power of 6 as an exponent on top, divided by z times z times z times z. That's z to the power of 4. There's 4 z's. That's a z. For anyone who's wondering. Okay, what about this? What do we have on top? What do we have on bottom? On top, we've got 1, 2, 3, 4, 6s, so that's 6 to the power of 4. We've also got 3 x's, x being multiplied, so that's x to the power of 3. That's what that means, right? So that's on top of this fraction. What do we have on the bottom? Think to yourselves, right? We've got 6 times 6, that's 6 to the power of 2. And x times x, let's say 1, 2, 3, 4, 5, 6. So that means x to the power of 6 on the bottom, if we were going to write that as an exponent. So we can expand an exponent out and write it all out as multiplication, repeated multiplication, or we can look at something that is expanded out as repeated multiplication and simplify it back to an exponent. I feel like I'm playing an accordion when I do that. Anyway, okay, so let's take a look now. Let's try simplifying some of these expressions and see if we can learn some rules about when we are dividing exponents or some new properties here. So first one, we've got 7 divided by 7. What's 7 divided by 7? That's right. Anything divided by itself is 1. That's just 1, right? Why is that 1? You could think about the same thing would be true for 2 divided by 2, right? The same thing would be true for 8 divided by 8. What happens when we've got a numerator divided by a denominator and they're the same? Well, we've done this, I think we've seen this before. These two things, they cancel out. And it reduces just to 1. Right, so this equals 1. 8 divided by 8 would equal 1, right? We can divide these. 8 divided by 8 is just 1. It's itself. What about r divided by r, some variable? Same thing. It doesn't matter what, right? R can be any number, but any number divided by itself will cancel out top and bottom, and we'll get 1. The important thing here to remember is that numbers or variables, it doesn't matter what it is, if you've got the same number or variable, on top and on bottom and on the bottom, that's an and. Maybe I should write it out. Top and bottom. What happens when we have the same number on the top and the bottom? They cancel out. They cancel each other. So if that's important to keep in mind, because that's how we're going to get to this property that we want to get to. So now we've got 2 to the 6th, 2 exponents, right? 2 to the 6th divided by 2 to the 3rd. Well, I don't really know how to simplify that yet, but let's think about, what if we expanded it out, right? Let's think about expanding it out first and seeing what we can do with it. What do we have on top? 2 to the 6th means, if we expand it out, 2 times 2 times 2, 6 times, right? And that's on the top. What do we have on the bottom? 2 to the 3rd power. That means how many 2's do we have? We've got 3 of them, right? So now we've expanded out both the top and the bottom. And what can we do? Well, look, we've got the same number on the top and the bottom. Every time we've got the same number, each pair can cancel out. So this pair will cancel out. This 2 with this 2, this 2 with this 2 will cancel out, and so will this one. So really we're left with 2 times 2 times 2, or 2 to the 3rd power, if we then re-simplify that as an exponent. Interesting. What's a shortcut way we could have done this? Well, each of these on top, or each of the ones on the bottom, canceled out one of the ones on top. So in other words, we could have just subtracted the exponents. We could have just saying we've got 6 on top and 3 on the bottom, so 3 of them are going to cancel out, so we'll be left with 3, right? And that canceling out means that really we are subtracting these two powers. That's a shortcut to get to this answer right here. So this first rule that we can think of is that when we divide two exponents, we can simply subtract their powers. Subtract the powers to get that. It's a shortcut. Remember, all these properties are just shortcuts for how to get to the final answer. Easy way to think of this. 6 minus 3 is 3. Because we had 6 on top, so we canceled out 3 of them. Okay, well, let's see. If we continue with that, think about that. I should maybe have put a couple more examples. We'll do more examples here. Let's see. With x to the 2 divided by x to the 5. Let's expand this out again. We've got x times x. That's x to the 2. That's 2 of them on top. What do we have on the bottom? We've got 5 x's on the bottom, right? X times x times x times x 5 times. Okay, again, what can cancel out here? Well, we've got an x and an x, that can cancel, and we've got another x and an x. Okay, so now here's a tricky thing. We've got nothing left on top, right? And this always bugs people. Like, what's left if it all cancels out? What's left? We can always say times 1. There's always, like, we can put times 1 there, because multiplying by 1 doesn't matter, right? It doesn't change what it is. So there's really a 1 left. So really this works out to 1 divided by, let's resimplify this, and maybe I'll make this a little smaller. Let's resimplify this. X times x times x. We've only got 3 left, so that's x to the 3rd. Okay, interesting. If we expand it out and then we simplify, we've got 3 left on the bottom, right? Makes sense. But what about this subtract the powers rule? We were supposed to take the top power minus the bottom power, and that's what power we get here. So if we use that rule, subtracting the powers says that 2 minus 5 should have given us x to the what? 2 minus 5 should have been minus 3, right? Because 2, if you've got 2 and you subtract 5, you end up with negative 3. So this is interesting. According to our subtract the powers shortcut, we're supposed to end up with a negative here. Right? But if we just simplify it, if we expand it out and simplify it, we get 1 divided by x to the 3. So this is actually our second property for today. These are the only 2 properties we're going to talk about. One is this subtract the powers property, and the other one is this negative exponent. What does this negative mean? A negative exponent really means, and I should probably just put this down at the bottom. I'll go back down there and rewrite it again. But what this says is that a negative exponent, a negative power just means that we put it, it's the same as a negative power is equal to, how should I say this? It's the same as 1 divided by that exponent to the positive power. Is the same as 1 over the positive power, positive exponent. Kind of cramped for space here, but hopefully this makes sense. This is kind of like a definition for negative exponents now. So if I asked you to rewrite x to the minus 7, right? Here's a negative power. You might be like, wait, what negative power? What are you talking about? That can't be. You can't have negative powers, right? Like, power means like that's how many times you multiply it by itself. You can't multiply it by itself negative times. But if you think about it, what's the opposite of multiplying? It's dividing. So really what this what this rule says is that this is the same thing as dividing 1 by x 7 times, or 1 divided by x, 7 times. Or we could rewrite this as 1 divided by x to the positive power of 7. Positive power of 7. And that's our negative property, our negative exponent rule. Okay. Similarly, if we have a negative exponent on the bottom of a fraction, if we had it on the top, right, like this, then we flip it to the bottom. Basically, this says put this on the bottom and make it a positive power of 7. If it's already on the bottom, like here, 1 over x to the minus 2, then we're going to flip it to the top. That's what we're going to do. So this is going to be equal to, and it's kind of hard to explain that, so you just kind of have to go with it. This is actually equal to x to the power of 2, of positive 2, on top, on the top of the fraction. So you don't have to write over 1, you could just say x to the power of 2. I guess I could write over 1, flip it to the top, but this is just, anything divided by 1 is just itself, so x to the power of 2. So here's another thing to remember. If there's a negative power, I'm going to say negative power is on the bottom, on the bottom, we can, of course, I write it something like this. On the bottom, we can flip it to the top and make it positive. Is the same as a positive power on top. I think I need to explain that. I'll try to diagram. Let me write this again. These two rules on the bottom, on that kind of page, that notes page there. To make this a little clearer, let me go down for a second. Let me kind of re-explain these rules. So we've got these previous ones, right? Multiplication property power rule from last time. And now I'm going to add the division property. Okay. Division property. And you can tell I haven't written it in a while. Which says that, what's the division property? That was like if we had the numbers, say 3 to the power of 5, again, divided by 3 to the power of 2, these two exponents. What do we do with these? This is the same as 3 to the power of 5 minus 2, or just 3 to the power of 3. In other words, what can we do? And when we're dividing two exponents, we can subtract the powers. When we're dividing these two exponents. And then we've got this other thing that I was kind of probably a little bit tricky to think about, was negative exponents. How do we deal with negative exponents? Let me try to provide a couple of examples here. So we had something like, let's use a different number. Let's say it's 2 to the 7th, right? Let's say we had 2 to the minus 7, to the negative 7, sorry, to the negative 7th power, that's the same as 1 divided by 2 to the positive 7th power. So with negative exponents, if we've got a negative negative power here, my shorthand is that it's going to be equivalent to 1 divided by that thing to the positive power. And another example of this is if the negative was on the bottom, if I had 1 divided by 2 to the negative, if I had 2 to the negative 7 on the bottom of the fraction, that's the same as I could flip it to the top. I could say it's 2 to the positive 7 power on top. Hopefully this kind of makes sense. So if I've got 1 divided by a negative power, or if the negative power is on the bottom, what I can do is I can change that to a positive power on top. And that's our negative power rule. So if you see a negative power, you can make it positive by putting that exponent on the bottom. If you see it, if it's negative and it's on the bottom, you can flip it to the top. Hopefully that kind of makes sense. This becomes positive and flips to the top. This one becomes positive, but the exponent gets flipped to the bottom. Okay, so let's try to do a couple of examples here, just some kind of wrap it up here with some more things. And if you don't kind of get that at first, that's fine. That's what practice is all about. That's why we do this. So let's see. We've got x divided. Okay, what makes this a little tricky is we've got x's and y's, right? Just treat them separately. Think about the x's on their own, ignore the y's, and just think about just the x's first. X to the 14 divided by x to the 7. Well, that was our division property, right? So what's the shortcut there? We can just do x to the 14 minus 7, which is x to the 7. Same thing with the y's. Now we treat the y's on their own. Y to the 5th divided by y to the 3rd, we can just do 5 minus 3. That's y to the 2. What about this one? Move w to the 8 over w to the 2. We've got w's and z's, right? Again, treat them separately. Just think about them as separate variables, right? W's aren't the same as z's, so try to treat them differently. Or not differently, but separately. So we've got w to the 8 over w to the 2. What's that? We subtract these powers. W to the 8 minus 2 is 6. And then what do we have here? Z to the 3 over z to the 7. Well, we could do the subtraction thing again, right? 3 minus 7. Z to the... What's 3 minus 7? Oh, that's negative 4. Oh. But I don't like this negative power. So how can we rewrite z to the negative 4? Well, remember we can change it to z to the positive 4, but put it on the bottom. So what I can change this to is z to the positive 4, but put it on the bottom and leave w to the 6th on top. Hopefully this kind of starting to make some sense. I'm going to cut the first part of this video now because it's probably way too long already and move on, and I'll do some extra practice.